Welcome back to Math Mini Lessons. My name is Sarah, and in today's lesson, we're going to solve equations with variables on both sides of the equation. Let's get started. So looking at this equation, you'll notice I have an x on both sides. And so it's not just simplifying, combining like terms on one side. I have to somehow combine like terms onto one side of the equation. So somehow, some way, I need to make sure that all the x's are on one side and all the numbers are on another side. So I'm going to just start by writing my original equation here, and I'm going to give myself some space to do a check on the other side. And I'm also going to rewrite the original problem. So when I figure out what x is, I can do some substituting. Now, I will say that it doesn't matter if you want your x's to go to the right side, if you want your x's to go to the left side, doesn't matter. Just make a decision. You're probably going to spend more time thinking about which one to move than if you just moved it and did what you knew you had to do. So don't get paralyzed by decision. Just choose a side and move your variables and your terms around. So I'm just going to decide that I want my x's here on the left, which means I'm going to take this one here and I want to move it to the side. So I'm going to create a zero pair by doing minus 6x on both sides. This will cancel, and 2x minus 6x is going to be 4x. I use my money analogy. If I have $2, but I have to give someone $6, I owe them money, and now I'm less $4, so I still owe them money. So negative 4x plus 8 is equal to negative 12. I only want my x's here, so I need to move this one now. So we're going to do the same thing. We're going to minus 8 on both sides again because I want a zero pair, and that's going to leave me with negative 4x on the left and negative 20 on the right. So again, I owe $12 and I owe another $8. Now I owe $20. And now I'm down to just one step. Negative 4x is equal to negative 20. I want the x to be isolated, so I'm going to divide both sides by negative 4. And so my x is going to be equal to 5. And we're going to double check our work because, again, we are our habits. Everything we do, if we're consistent, it is going to pay off. So we know that good habits are to check our work. So let's just do it. And I'm going to substitute. Every place I see an x, I'm going to put a 5. So 2 times 5 plus 8 is equal to 6 times 5 minus 12. I'm going to start with the left. 2 times 5 is 10. 10 plus 8 is 18. On the right, 6 times 5 is 30. 30 minus 12 is 18. It is balanced to have the same solution on both sides. So hit pause, jot this down into your notes. And we're going to try a more spicy problem in a second. We're going to use the same thinking as before, where we have to just make a decision. Where do we want our x's, on the left or the right? And we're going to follow through on the process. Move all the constant numbers to one side, all the x's to the other. Fair warning, just by looking at this problem, you're going to notice that it is spicier than the last one because of this fraction. Meaning we're going to have to do some fraction work. It is going to make it a little bit longer as a problem. But again, this is about just being persistent and consistent with our habits and just having that confidence that we know how to do this work. So we're just going to go in knowing it's going to be spicier, and we have to just use a little bit more of our fraction work in order to solve, and that's okay. So let's start by just rewriting the problem. 2/3 x plus 5 is equal to 8x minus 39. We're going to make a decision, and I'm just going to decide that my numbers are going to go here and my x's are going to go here on this side. Just making a decision. And I just have to move them. I just have to make a choice to move the numbers. So I'm going to decide, in this case, I want to move my numbers first. So I'm going to do plus 39 on both sides. And you can try it and see, like, if you had moved the x's, would you come out with a different answer? And you shouldn't, because the algebra will be consistent. If you're doing your steps correctly, your processes, you're going to come up with the same answer. All right, so 5 plus 39 is going to give us 44. And we still have 2/3 x plus 34 is equal to 8x. Now I need to move my 2/3 x, so I'm going to subtract. Minus 2/3 x on both sides. And this is where the spiciness actually starts to come out, because we have to subtract with a fraction. So don't fret. Just don't worry about the feeling part. Just think, how would I subtract this number? I need to do some regrouping, so I'm just going to turn this into 7 and 3 out of 3x minus 2/3 x. Okay, nice and calm. That's going to give us 7 and 1/3 x. Again, it's just because of the fractions that make it more challenging to do, but take it a part at a time, just one step at a time, and just do what you know. You have these skills and you've been taught a lot of this information. And if you're not sure, go back to previous lessons from 7th grade and just do some more review. That's all it means. If you're struggling with the challenge, it just means you probably need more review with fractions. Going on, I want to isolate that x, so we're going to divide by 7 and 1/3. This is where I'm going to want to write it in a standard form. So 44 over 1, because instead of doing it as a complex fraction, is divided by 7 and 1/3 x. Oops, sorry, 7 and 1/3 is going to be equal to x. And we're going to think through, how would we have solved this before? Well, one thing, let's change that improper fraction. So let's just think there. And we're going to do that by multiplying. So 7 times 3 and then plus 1. So 7 times 3 gives us 21, plus 1 is 22. So divided by 22 over 3. Stay with us, Math Marvels. It's spicy, but we can get through this. Is equal to x. All right, so luckily our work still looks very, very neat. We still have more parts on the page. So let's continue on. We're going to take this, and we're just going to move it here to give us more space. 44 over 1 divided by 22 over 3 is equal to x. To divide a fraction by a fraction, remember, you're going to do keep, change, flip. So 44 over 1 times 3 over 22. We multiply by the reciprocal to get x. 44 times 3 is going to give us 132. You use your calculator. If need be, 132 over 22 is equal to x. And our final step, just do your division. 132 divided by 22 will give us 6. So yes, this is a really challenging problem. It is a problem that had lots of steps because we had a fraction in it. That happens sometimes, that's okay. We still have to do it one piece at a time. But as always, although I know part of us probably wants to stop doing this problem altogether, let's just go back and do a check. And we're going to write our original 2/3 x plus 5 is equal to 8x minus 39. And now we're going to substitute 2/3 times 6 plus 5 is equal to 8 times 6 minus 39. I'm going to start on the right side just because it'll be a little easier to do. So let's do 8 times 6. That's going to give us 48. And 48 minus 39 is going to give us 9. 2/3 times 6 over 1, parentheses, plus 5. So 12 over 3 plus 5. 12 over 3 is the same as 4 plus 5. I'm getting excited. Boom! I get the answer 9. 9 is equal to 9. And whew, this was an endurance test, Math Marvels, but just by going piece by piece, we are able to do this problem. This was a challenge because it required us to just remember how to do lots of different skills with fractions, but we were able to succeed and we are done. So hit pause. You can put this into your notes for today. And our big takeaways, whenever you're doing an equation with variables on both sides, you want to just make a decision and put the same variable on one side. Either all the x's go on one side or all the x's go on the right. Just decide. And then use your inverse operations to move the other terms, the constant terms, to the other side. And then just use your algebra skills to work through it and identify what the variable is. And finally, just consistency, check your work. That's it for today. We will see you in the next lesson. Keep practicing, Math Marvels.